All right, I did pare down the oral questions for the final. Originally I had 15 on there. That's no fun. So I figured, then I saw Matthias's face like just dying. So I figured, okay.
Everybody is so drained.
Yeah, I could tell somewhat as well, yeah. So let's do this here. I pared it down to 6. That's it.
Yeah, but also COVID.
I don't know, you can blame COVID for anything though. So I'm not sure.
But, well, I didn't feel like this last year when COVID wasn't.
Yeah,
So
neither.
I don't understand.
I'm just gonna guess.
Got it. Okay, so oral final, here it is. And I picked just the basic ones, but at least gives you a flavor of the class as a whole. So there's 6 of them. You guys got this email from me, I assume, right? So there they are. It is going to be, we didn't do it in the beginning, right? We didn't do it first semester?
No.
Okay, so it's going to be, I'm going to pick one of those 6 randomly. It's going to be a sheet of paper or something like that, something along that nature. And you're going to go to the front board. You are going to explain the problem. As you're explaining the problem, please give me as much detail. If you're going to use a formula, write down the formula on the side. We're good. And then use the formula, compute it, and done. That's it. Rubric pretty much is speak clearly enough for people to understand in the class. And I should make a rubric. I'll make a rubric for that here. Just doing the problem without any corrections whatsoever that's needed, right? Should be another 3rd thing or so like that. It's essentially it is 20% of your final overall score. We good? So your written final is 80%, and then this is going to be 20% of your score, and that combines to your sort of final grade in the final grade.
Final going to be for both semesters, like cover all of the material, or just?
I believe it will. Yeah, it's the whole final. So it goes all the way back to 1.1.
Is there any possibility we could throw out the presentations just because we'll be studying for this and then all of our anatomy stuff?
Gotcha. What do you guys talk to me? What do you guys say?
Yes.
Yeah.
We have a lot on our place right now.
Yeah.
Oh, I just finished my presentation.
Get brownie points.
Yeah, the presentation should be extra credit, like a lot of us did.
Look a lot. Okay, screen slayer. Okay, we'll back on it.
I just have no motivation going to the end of this year, so it's really difficult for me. If you really want to do it, I'll do it, but it's just for me, it's gonna be really, really difficult to muster up all that motivation to get that done.
How about this? How about this?
That part.
It's not.
Since we didn't do it,
This is fine.
I'll do a compromise, Aiden.
It is just.
Compromise is if you can pull up your presentation from last semester, and if you want to do that still, just to present it, that's fine. So that'll be like no extra. If you want to present something new, that's cool too. Okay. And then I'll give you a little bit extra credit if you want to present something new, because that should show some effort that you've done something. But since no one saw those, like blood spilling in a crime scene, that was actually pretty cool. Disneyland was pretty cool too. So all those ones are like that is so awesome. So dig it up. It would be nothing new for you to do. Just present it.
Yeah.
Once again.
I can add more onto my lap.
Yeah, that'd be fine too. Yeah. So something along those lines. I think that would be a good way to do it. I do want to present. They were actually pretty cool. So I want to share with the rest of the class that's neat. Okay, I'll go with that. Okay, written final portion. Here it is. It does go all the way back to the beginning. This is pretty much one problem per. So if you want to go back to 1.1, find the instructions in the homework that says that. And I literally will just pick a problem and change the numbers just slightly, so it won't be actually part of the textbook. And there's your final sort of thing. Okay, I probably. So you have those. If you have any questions to ask me whatsoever, go for it here. There's a non-calculator as well as a calculator part, and then I'm going to throw in some extra credit in the process. I think there's 16 questions, I believe. Let's see, let me count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 14, 15, 16, and then I think 3.
Take it in a 15-minute class.
Yes, correct.
Oh,
So
wait, in 15-minute class?
50.
For the oral final, can we have the book to just like read the question out, just to like jog our memory, like specifically what the question is?
Sure, I will have it. I think I'm going to post up here so you'll see
perfect.
it. And I'm going to I'll either do something random where it randomizes the next one.
Okay.
Sort of thing, I'll go from there.
You just put them in a random order on slides.
So,
and we each do them.
We're all gonna, so there will be some repeats of it, so like we'll see a classmate do the same one, then we might do the same one.
Yeah, and I'm gonna try to figure out how to do it so that it's not like the same one going after the same person.
Yeah.
Yeah,
Because
Memorize
that's
what
not
they do
fair,
for you.
yeah.
every single person
Regurgitate,
does the
let's
same
just
one.
have- just have 6 people in a classroom at a time.
So we can
Hmm.
write
Check
it
the
up
rest
on
of
the
us out.
board, it's not just like reciting what you're doing.
So what you have to do is you have to go to that homework question already, go to 1.4, go to 43, and you do need to practice
Yeah,
that problem. So verbally, to the mirror, if you like, to the sheet of paper at your desk. As you write down this problem, you're actually talking about it. If you need to use a formula, then write out the formula on the side, saying this is the summation formula, the sum formula for sine. And this is the formula here. I'm gonna put it in. A is equal to 1/2, B is equal to √3/2, plus.
so it's
and then-
not like we can talk about it and write it on the board, we just have to talk about it, but you can also write it down as you're saying it.
That's the way you would practice, yeah. And so when you do it on the board here, you are gonna explain it as if you're teaching the class.
Oh, okay, I thought you were saying when you're actually doing it, you're just saying it, you're not
Oh,
like
gosh, no.
showing everybody.
Yeah, no, as you're practicing it, yeah.
Okay, yeah.
As you're practicing it, make sure you verbalize
Yeah,
what you're
that makes
saying and what you're doing. Mhm. So you're teaching the class that problem, essentially. Adrian,
So like we are gonna have a formula sheet, right? Or.
to go up to the board for the oral final, no, there's nothing given whatsoever. So if you have a formula that you need to do, that is gonna be memorized. Yes, So no formula
Oh,
sheet.
dodge it last minute.
There's no graphs on here either. This is just, is there graphs? No, 4.3 should be a graph. Let's see. Yeah, it is a graph. Sorry. Yeah, one graph on there as well, because I do need to give you a sort of a graph thing as part of class. Okay. It'll be no variation in the problem. It's that exact same problem. All good? So it's just a memorizing of that. Okay, are we good there? Okay, schedule wise here, let's jam to that just so we have it here. So final day of new material here, 7.5. Presentations, here we go. Everybody still okay with those right there? Even if you get old stuff together, we go from there, or if you get new stuff. And then if we need to talk about the oral final, we can talk about it some more on Friday as well. Good. Okay. Whew. Feel like a lull here. You guys just
We've just.
surviving.
Yeah, we're just mentally defeated.
Okay.
Yeah. Pretty much.
Yeah, basically like 4 finals and anatomy as well, so. just-
4 finals?
Yeah.
Well, there's
There's like 3 tests
Or
this
like
week,
Mark,
and then
really
we've got
bad.
like the
The
final
final
next week.
Wow.
Unlike Mark,
we're all
they're
very
not
done.
invincible.
It's a good time.
Is it next week or the week after?
I think it's next week, but it's due the week after.
Yeah.
Oh.
I might have made that.
Unlike Mark, he never thought we were.
When she gives us the study guide
That's
next
more
week and we
accurate.
have
Yeah.
all. that stuff.
Yeah, it's the answers written out, so
Oh, yeah, true.
I don't know what she'll do with that, but.
Okay, let's go with it here. I got to backtrack here. I did make a mistake on Monday, my first one ever in mathematics. If you can believe that. So if you guys can go back in your notes to example 2, that's the one that we got 5.32 feet squared. And as I redid the problem, thinking, why did I get that first time? Because I did do it 2 o'clock in the morning, but I did it incorrectly 2 o'clock in the morning. I forgot to do a square right here. So according to the formula, that should be b squared. When I wrote down the, when we did the problem in class, I just put down 2.72. So if you do put the square in there like you should, then this, anyone can recalculate this for me, please, here. What's 2.72 to the second power times sine of 90 times sine of 75/40?
Yeah, I got 14.5
Okay,
squared.
thank you so much. Okay, so if you guys go back in your notes, that should be the correct answer. There is not the 5.32. So scratch that out, put the correct one in there. Part of teaching mathematics is you're supposed to get the correct answers. And it's feet squared. So this area of that triangle. All right, let's see what's the other thing. So I did drop, yeah, we dropped the chapter 7 test as well, right? Because that's the whole point of. Yeah, initially we were going to do a chapter 7 test as a take home and then turn around and do the other stuff here. So that would be overwhelming. Okay, let's jam. Here I think we only have 5 problems here, but there's a lot of understanding first. Okay, so I want to jump to something called vectors. Have we done vectors before?
Yeah.
Just a little bit.
Yeah, just a little bit. So what we're not going to get to is 6.7, which is a whole bunch of other stuff with it. Like how do you calculate work with vectors, right? We're not going to get to there. But we're just going to do the intro to it. We're going to do the addition of them and subtraction of them, sort of like the algebra of vectors. That's what we got today here. Okay, so let's jam. This is, hey, look at that, vectors and algebraic approach. All right. Yeah, we just did them in terms of what, in terms of a degree value, right? From true north, we did them that way. We did them in terms of that's right, a stationary thing, like that light post that was hanging on 2 wires. I remember that. Surprising, I remember that. Okay, so we're going to do the algebra of vectors. Okay, I'm going to talk a lot and then we'll do a problem. Then I'm going to talk a lot again and then we'll just do another problem each time. Good, as we do them. Grab this guy just in case. All right. Almost there, almost there. Let's go. So draw it right in terms of I and J. This is a lot of stuff in engineering that we do it just a quicker way to write it. Then we're going to talk magnitude and then of course add, subtract, and multiply these little vectors together. So let's jam standard position of vector. Again, talking a lot and then we'll do a problem. And problems I designate as example 1. That's cool. All right, so vectors, here it is. What we do is we start a vector at 0, 0. We have a point called AB, and the length of this is very, very important because the length of it determines the size or the magnitude of something. So if you're traveling in a car and you're going 55 miles per hour, that length is going to be designated as 55 units or maybe 5.5 units. It's going to be some kind of scale there. If you're flying on an airplane that direction, 100 miles an hour, this guy should be 100 units length somehow. We're good. Okay, jam, next one. How do we write them? What's the easiest way to write them? Instead of writing them as AB, because it could be confusing. It could be that you're thinking about AB as a point called AB over here. So in order to say, yes, we're doing scalars and we're doing vectors, what we do is we write it like that. It's this little, kind of like, I don't know, what do you guys call that? I don't know. Sideways V. I'm thinking like extended less than sign and extended greater than sign, I guess, you know?
French brackets.
Okay.
That's true.
Okay. So what's inside here is that A is going to be your horizontal component. It's how much you go sideways. B is going to be your vertical component. That's cool. So it does give you almost like vectors of each kind. And so whenever we shoot a guy out of a cannon, right, we have a net, hopefully, right? But we think about it, even though it's a 3D view of things, we scale it back to a 2-dimensional object. He's going horizontally, he's going this fast, and vertically, he's going this fast. Okay, so far so good? Whoever needs to write down how much they need. We're good? Okay, so let's talk about magnitude now. we've talked about this before here. Magnitude of vector has these little, it's like absolute value markers, but with vectors, they just mean magnitude, is how fast something is moving. Usually it's how fast, so miles per hour, feet per second. Or if we talk about force, it's this much force of gravity going on something here. And so it is going to be the square root of a squared plus b squared, which really is just Pythagorean theorem again, is that right? And talk to me, did we talk about magnitude before of vectors? Yeah, we did that as well, okay. Okay, good there. Sure, absolutely. It is Pythagorean theorem. It's interesting. In mathematics, we eventually start running out of symbols. So let's do this here real quick here. I'm going to write that one, that one. Oh, and of course, this one. We have the little dash thingamajiggy, right? All three of those, they mean absolutely something different. Is that right? This is actually a negation of, it's the opposite of 3. It's a reference where it is on the number line. Correct? This guy means anybody?
1/3.
1/3 or reciprocal of 3, right? So this means reciprocal. Not talking about where it is on the number line at all whatsoever, right? It's actually taking a 3, it's an operation where it's flipping it into the denominators and numerators get flipped. This guy is an operation. It actually tells you to do something here, and it tells you to subtract, but in all 3 cases, totally different things, same exact symbol all 3 times. So same thing here. It looks like an absolute value. It is not an absolute value, it's magnitude. Terms of vectors.
What does the first one say for -3?
Number line. It tells you the identification where it is on the number line. It's a negation of 3 or a negative of 3. Okay. Example 1 finally. Da, da, da. So can you draw the vector -2, 5 in standard position and find its magnitude? All yours. Now you can write. Let's see here. Do they give? Yeah, it looks like they want. Give exact values. So boom, has to start at the origin for sure. Let's see, it's going to go -2 this way. It's going to go 1, 2, 3, 4, 5. So the vector is going to end right here. I'll put a little dot for now. But really what I want is I want to graph a line from the origin to that little dot. And now I'm going to put a little arrow next to it like this. And there's my value there. Again, could be wind speed, could be the wind that's hitting the boat at a certain direction, could be the boat heading that direction, or it could be a force that's acting on an object at that point right there. So all those 3, all the same way right there. And of course, we're going to put trigonometry on this here, right at the end here. Okay, talk to me. Are we good? All right. Anybody else need more time? No? Okay. Keep on jamming. Hey, to tell me if you need more time here. Okay, good. Okay. All right. Let's add some.
Find the magnitude.
Yeah, that's what I was.
Oh, sorry. We should do that too, huh? Okay, let's go with it here. So thank you. Kind of helpful to actually do the directions. 4 plus 25, is that right? So for the homework, and it's because it's math class, not physics class, we keep it as an exact answer here. So square root of 29 is good to go.
You can just leave it.
Leave it just like that, yeah. Cool. Okay, now we're good. Add, subtract these things here. Let's do a little bit of algebra here. Again, me talk a lot for now. So whenever you're adding and subtracting vectors, we always put them head to tail, always here. So we bring, that's not head to tail. It should have went this way here. And so the sum is a wrong picture. I wonder if it's in the textbook here. Oh, it's U and V. Okay, sorry. So real quick here. So we have U as this red line right here. That's what we start off with. And notice it is in the right position. Oh, you know what? Let me do this here. Da, 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 da. Is that a lot better?
Yes.
Awesome. Okay, U is 6.2. So graph's right here. V is -3.5, which is graphed right here. If you're going to add them, we always add them tail to head, tail, or head to tail, all the way through. And so we are going to slide this over. We're going to put it at 6.2, and we're going to see what are the conditions from 6.2 goes here. So this little blue line is the addition of those guys together. We're good. And so it is speed of the boat, or the direction the boat is headed. Waiting for that guy to pass. Okay. And then this is the wind. So by the time everything's said and done, the true course is actually this way of that boat. Not cool. So let's add these together. Visual clue here is this 2 right here. I have. Oh yeah, that's good. So I made a little visual. Let's see if this works here. It goes like this. Does that make sense? Head to tail, and then we add them up. They should be right over here.
So you always have one head touching the other tail.
As you put them together. So this would very much be like a ship in the ocean, and the current is going a different direction. That's a lot more of how you would sort of see it here. Airplanes. Now with jetliners, what we do is we go into a jet stream usually here. Did you guys know that there's like wind currents that are below, wind currents are above? So with airplanes, they hit a jet stream going south or north or east or west, right? And they usually will go with it here. And then you still have storms that come your way, right? That actually disrupt that jet stream. And so there's a lot of cool stuff that happens in the air. Okay, how about subtraction? What happens here? So notice I still have my 3, 4 right over here. But my blue line, the V line, what I do is I flip it the other way because I'm going to be subtracting. So it flips down this way. And then at that point, I'm gonna add it, but I'm technically subtracting because I just flipped it across. So that little dashed line now gets moved. Are we good there? And then we wind up with that vector there.
So for addition, you moved it to above. Facing the same direction, you just shifted it up so that the head hit tail. For subtraction, you flipped it the other direction and then still had the head meet the tail. Okay.
And let's do the work at it. Let's see. You guys talk to me here. Let's zoom in again. That is at 5, -1. Is that true? You guys agree 5, -1? If you're awake, 5, -1. Cool. So then let's do this here. Let's add. Let's see if I get there. If I do u minus v, right? I'm going to do a 3, 4 minus -2, 5. And if we do individual component parts here, 3 subtracted -2, what do you guys say? 5. Oh, cool. It works out algebraically. Hold on. 4 minus 5. Sweet. Okay, is that good? So it actually works just by the numbers themselves. Let me go back to the previous one real quickly here, like this. If I were to add these guys, 3 plus a -2, 1, 4 plus 5, 9, and is that where this guy hit as well? I think so, right? There it is, 1, 9. So really what we do is we just add the component parts to them. That's cool. Example 2. Oh no, never mind. Hold on, we're gonna look at vectors first. So how about scalar multiples here? We're gonna make this guy 3 times bigger. So if we look at this here, this is at -2, 1. Everybody agreed there? Make it 3 times bigger means it's gonna go like this. It just stretches out 3 times further. Okay, where we're at? I think we're at -6, 3, is that right? Sorry, making sure. Oh. We good there? 2, -1 first. And then we're gonna go with -6, 3. Okay, question is this. If I made it 3 times bigger, does the algebra follow? If I were to take this, notice it's a multiplication this time, right? It's a 3 times bigger multiply. So if I multiply each of the components, that's cool. So the algebra works out with vectors just easily, just like with numbers. That's awesome. As if like someone planned it, you know? It's kind of the craziest thing. Bias maybe planned it. That's right. Okay, let's go with it here. So can you do this here? Example 2, go for it here. So I have 4, 5, I have a -7, 3. Can you add them together? B, can you do scalar multiples of them and subtract them? All yours there. All right, A is pretty easy. A is just the addition of those guys together. If you want to show the addition, you can even go like this to show the addition, or you can just do it in your head. Those are pretty easy here. 4 plus -7 is going to be -3. Guys, make sure I don't mess up here. Then I got 8, is that right? 5 plus 3? This one is going to be a multiplication first. Before we do that, then it'll be a subtraction of them afterwards. So how about 16, 20? Subtracting from -35, 15. So notice you multiply in the +5 into it. I guess if you multiply the -5, it'll be okay too, because then you just change everything up here. All right, help me out, please. 16 subtracted -35. 51. I agree. 20 subtract 15. I'll do that one. I got myself a 5. Everybody okay there? Okay. Okay. That's the algebra of things here. Now let's put in some trigonometry stuff to it here. So we're going to go vector components. So now I want to do this. I have a vector, but I want to see exactly how much is it going horizontally and also see how much it's going vertically. I want to sort of break it up into its pieces there. So what we do is we write, instead of V, what we're going to do is we're going to write Vx. The little subscript X just means we're going horizontally. And then the subscript Y just means we are going vertically. And let's see. That's right. Remember how we did those parametric equations? Remember that? We had one t value going one way, t value going the other. It's exactly what we want to do with these vectors here. We define them as individual pieces. And we can also put them together. So let's see how that works. And this is the best way we found to put them together. And the easiest way notation-wise. Okay. So we need two special vectors. One's a horizontal one, one's a vertical one. And so let's do this. I'm going to call one of them, this little piece right here, the horizontal one. I'm going to label it as 1, 0. Good. But it's just going to be, I'm going to write it as an I value. So whenever I see I know that that's going to be the one that goes horizontally.
Is
J-
that always the case?
Uh-huh. And then J is going to be going vertical. It's going to be the vertical component here. So let's see how this works itself out real quick here. Again, I'm going to talk a lot and then we'll do a problem. And hopefully finish now here. So how about this? I'm going to write, instead of V is this little funky notation with -4, 3. I'm going to put it into its vectors here. Example 3. Sorry, I have to write it down. All right, with unit vectors now. So instead of it writing as -4, 3, which kind of doesn't lend itself to algebra too well, I'm going to write it like this. So the I component is going to be hooked up with that -4. The J component is just going to be worked up with 3. So that whole piece now is just -4I plus 3J. Okay, what does it allow me to do? Allows me to do a whole bunch of stuff here. I can multiply two of them together now easily. I could put them into equations and solve them, or this I can't put into equations and solve. So it lends itself to a whole bunch of algebra uses. I can, in calculus we say take derivatives of them, so I can integrate this. I can do a whole bunch of stuff now because it's just adding, subtracting stuff together. Cool, okay. So let's go with it here. Another definition. So there it is. V now is AI plus BJ. Magnitude still stays the same. No change there. All right, so magnitude still the same. And if you do want to draw this here, but no, you got, here it is, if you want to draw that little piece there. But I think just right here, this is the main point right here, is the fact that we've changed it to just adding two components together as opposed to a coordinate system. I'll wait a little. And, all right, let's jam with it here. So exercise 4. So I have a vector called V. Tail at the origin. It makes, hey, look at the angles now. I think I got this here. It has an angle of 30 degrees with the positive x-axis. It has a magnitude of 8. That's cool. Can I write V in terms of I and J? That's my next question. So let's see, let's graph this at least. Let's make a little graph of this guy. I have, here's my vector. I can say it's out 8 units. I can put this on top. I can write this as a 30-degree angle right here. That's cool. But now the question is, what's the A value that multiplies I? What's the J value or the B value that multiplies J? So technically what I want is I want this little guy right here. I want v sub x. And then I also want the v sub y component. Okay, that'll be good there. I like the fact that we can put it into an angle measurement. That's kind of cool. So hold on though. This little v sub y over here, could I kind of technically move it? Could I move it over here? Would it be the same thing as writing it like this? That okay?
Well, the heads are both together, but is that fine?
Yeah, that's probably not.
Yeah, so because this is the addition of both of them together technically, right? It's the vertical component here and the horizontal component. So I got each of them as components now. All right, talk to me. How do we get v sub y or v sub x? What do you guys think?
Could you write it as sine of 30 degrees equals Vy over 8? And then solve from there?
Oh, perfect. This is just trigonometry, right? Actually, basic trigonometry, isn't it? If we just look at v sub y, isn't this going to be sine of 30 degrees is opposite over hypotenuse, isn't it? That's so cool. So hold on. So that means if I multiply the 8 out, this becomes 8 sine 30 degrees. Is that good there? So technically there's a magnitude times that. I wonder, just real quick here, is there, I don't think there's a formula. There's no sort of written formula for it here, but can you guys give me this here? What is 8 times sine of 30 degrees? Anybody with a calculator? Or if you know it on the top of your head. Make sure you're on degrees. That would be helpful.
Is it 4?
4, perfect, because sine of 30 is 1/2, so half of 8 is 4. Perfect. Okay, the other one, let's see if we can write it without having to do the basic stuff here. Is that okay with just putting 8? It's going to be cosine now, cosine of 30 degrees. All right, without putting away your calculator yet, what is 8 cosine of 30 degrees?
6.928, so.
6.92, 6.9 is fine.
Yeah.
Cool, okay, I think I got it here. So this is 6.9i plus 4j. Tell me if you guys agree with that. Good, maybe sometimes. Sometimes, yep. Only on Wednesday mornings, that's about it. All the rest of the time,
Yeah.
vector algebra breaks. Okay.
So is the equation like equal to when we write out the point on the graph, like the weird parentheses with the A, comma B? Is it just like this, it's equivalent?
It's
to
equivalent,
that?
yeah. I could write it like this. I technically could write it like this. If I'm looking at components, that would be the same thing right there.
Okay.
If I want to write it. This one makes it a lot easier. Again, you can FOIL this out now, right? You can do a whole bunch of algebra with this here. You can factor it if you need to be. It lends itself to a lot of.
So you might have already said this, but why aren't they just regular parentheses? Why is it those different shapes?
You guys, yep, because it's not a coordinate in space. It's not 6, 4 out here. It's a magnitude of this going to it.
Oh, right, it's not like a point, it's just showing that.
It's the end of the arrow, yeah.
Okay.
Yeah, perfect. Good question, you guys, seriously. Part of learning is that when you're learning something new, right, you're trying to put pieces together and like, hey, what is that component again? So, perfecto. Okay, real quick here. Can we do it the new way now? Can we do it the algebra or the IJ way here, besides Matthias? So same stuff that we did before, just putting I and J.
Like negative 3i?
That's a negative 3i plus J. Mhm. Here. j. If you want to put in parentheses, sometimes they're written in parentheses like this. That's fine, but essentially, we still have.
Can you just say I, not more?
Just I, I minus 6j. Cool. And make the j a little bit nicer looking. B is 4 times, look, minus 5 times all of that. So 16I minus 28j looks like. Now I can multiply it as a negative 5 too, because that makes it easier here. So how about 15I minus 5j? Good there. And just make sure I'm honest here. I think I got a 31I minus 33j. True. Cool. Okay. Let's see. Okay. All right. So 7.5 is really just this. It's really just the algebra pieces of it. We good?
This makes sense to me.
Cool. Awesome.
Yes, and actually, it has made the most sense out of all the chapters.
All the way from 1-1 to now, like, oh, I can do trig now.
Yeah. Only we could have gotten the polar coordinates and none of it would have made sense.
There we go.
Thank God.
Now, I did want to do this here real quick, since this is the first last day of sort of instruction here. I want to give like, what did we not get to? We did not get to 7.6, which is with vectors, we start doing something called dot products. And in physics, we call this work. Work is force times this little dot right here. That's what it is. Force times distance. So whenever you do forces, so it's that light that was hanging off of 2 cords, right? We can do this, and we can actually think about how much work is involved or how much strain there is on the cords to make that happen. There's that piece is there. And then chapter 8, bless you. Chapter 8 is complex numbers. Hey, you guys know complex numbers, right? It's like I is equal to the square root of -1. Remember that?
Yes.
So
yeah.
chapter 8 is complex numbers and trigonometry
Also polar coordinates.
and polar coordinates. So let me just real quick here. Let me go real quick. This is polar coordinates right here, since we didn't get to it. Just to really confuse Grant. This is for the sake of just making Grant stressed out. So instead of having like X and Y coordinate, right? Polar coordinates, what they do is they say, hey, look, we can actually go into the length away, hey, a vector in a sense away from here, and then an angle measurement away. And so you make a whole new system based upon that. And it's pretty cool because now you can build formulas. There's a straight line right here. There's a circle right here. And the formula for a circle is just R is equal to A. That's kind of cool. Then you can build some other stuff here. Here's basic what is it? Graphs in polar coordinates. Yeah, this is called a rose that goes like that. And again, this is to model nature, right? This is kind of what this is for. Model trajectories to the moon. This is model anything that goes circular in nature. This is what this is for. All right, this one right here, the 3-leaf rose. That's cool. We have these guys. They look like infinity symbols. Or limb skates. Okay. Cardoids go like this. They go out and then they come back in. So an out and come back in. And then limicons go out and back in, but they loop on the inside of things. And so they have those, which is kind of cool. Anyways, those are the graphs that we did not get to. Why do we do that? We do it in order to model anything that has a circular motion right here. So a piston going through a channel right here. We have, how about microphone and how microphones capture sound. This is kind of how it is right here. When you speak into a microphone, they capture sound in certain places. And how about this? That was kind of cool. There's something that goes up and circular and comes back down. Kind of useful if you're making a ride that should last for a while. Yeah, so anyways, I thought that was kind of cool. So there's the end of the lecture for 7.5. honor questions, there's 3 applications of this stuff. I'm thinking at this point you can skip it if you want to try it and you're like, Mr. and you've helped me out on it, I can give you the help on it as well, but they're kind of tough. Honor questions, the last 3 applications, you can skip those if you like. All right, anyways, you guys enjoy your Wednesday. I'll see you guys on Friday.
Yeah, that's
Da, 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 da. Absolutely. Thank you so much.
God bless your soul, Mr.
Thank you. Yours too, Matthias.
Oh, wait, we don't have school Friday, do we? Why?
No, we do have school this Friday.